Hello everyone, myself Jayanth and I am currently pursuing my BA in Sri Venkateswara College of Engineering and I am currently studying in second semester in the section Devo. The subject is Mathematics for CSE stream. The topic which we are going to discuss today is applications of curvilinear coordinates. Let's know about curvilinear coordinates. Curvilinear coordinates are a coordinate system where the coordinate lines may be curved. These coordinates are often more suitable than Cartesian coordinates for describing geometries and solving problems that involve curved surfaces or irregular domains. Curvilinear coordinates can simplify the mathematical formulation of problems by aligning the coordinates with the natural geometry of the system being studied. Common types of curvilinear coordinate system include cylindrical, spherical, and polar coordinates. Curvilinear coordinates are characterized by the fact that the coordinate lines are not straight, unlike Cartesian coordinates. Instead, they can be curved, making them ideal for describing nonlinear, complex geometries. The types of curvilinear coordinates are polar coordinate, cylindrical coordinates, spherical coordinates, elliptic coordinates, parabolic coordinates. Let's know about polar coordinates. Polar coordinates are a two-dimensional coordinate system where each point on a plane is defined by distance from a reference point and an angle from a reference direction. This system is especially useful for problems involving circular or rotational symmetry. Applications of polar coordinates. The first is physics. Circular motion. Polar coordinates are naturally suited for problems involving circular or rotational motion. For example, describing the motion of particles in a circular path, analyzing orbits, and studying phenomena like waves and oscillations. Electromagnetic fields. When dealing with problems involving circular or cylindrical symmetry, such as the magnetic field around a wire or the electric field around a charged ring, polar coordinates simplify the equations. Polar coordinates are applicable in engineering field too. The mechanical system. In mechanical engineering, polar coordinates are used to analyze systems with rotating components such as gears, turbines and engines. They simplify the study of stress and deformation in circular objects. Control system. Polar coordinates help in designing control system for robots that operate in circular or rotational environments like robotic arms and rotary encoders. Applications of polar coordinates in mathematics. Complex numbers. Polar coordinates provide a natural framework for representing complex numbers. Integral calculations. In calculus, polar coordinates simplify the computation of integrals over circular regions. For instance, evaluating double integrals over disks are annually becoming more straightforward. Computer graphics and visualization. Rendering circles and spirals. In computer graphics, polar coordinates are used to render circular shapes, spirals, and other patterns that have radial symmetry. They simplify the algorithms for drawing and manipulating such shapes. Texture mapping. Polar coordinates assist in texture mapping where textures are applied to 3D models, particularly those with circular features like domes in cylindrical objects. Let's know about cylindrical coordinates. Cylindrical coordinates are a three-dimensional coordinate system that extends polar coordinates by adding a height dimension. This system is particularly useful for problems involving cylindrical symmetry, where the geometry or physical properties of the system are invariant under rotation about a central axis. Applications of cylindrical coordinates in the physics field. Electromagnetic fields. Cylindrical coordinates are particularly useful for analyzing electromagnetic fields in systems with cylindrical symmetry, such as coaxial cables, solenoids, and cylindrical capacitors. Maxwell's equations can be more easily solved in these scenarios using cylindrical coordinates. Fluid dynamics. In fluid dynamics, cylindrical coordinates simplify the study of flow in pipes around cylindrical and in other cylindrical systems. For example, Navier-Stokes equations for fluid flow are more straightforward to solve in cylindrical coordinates for these geometries. Applications of cylindrical coordinates in engineering fields. Mechanical systems. Cylindrical coordinates are essential in mechanical engineering for analyzing stress, strain, and deformation in cylindrical objects like shafts, rods, and pressure vessels. They help in designing and evaluating components subjected to axial loads. Heat transfer. In heat transfer, cylindrical coordinates are used to model thermal conduction and convection in cylindrical objects such as pipes, reactors, and insulation materials. The heat equation takes a simpler form in these coordination for such geometries. Mathematics. Integral calculations. Cylindrical coordinates are advantageous for evaluating triple integrals over cylindrical volumes. For instance, integration functions over cylindrical regions or computing volumes and surface areas of objects with cylindrical symmetry are straightforward. Let's know about spherical coordinates. Spherical coordinates are a three-dimensional coordinate system used to describe the positions of points in space using three parameters: the radial distance, the polar angle, and the azimuthal angle. The system is particularly useful for problems with spherical symmetry, such as those involving spheres or circular regions. Applications of spherical coordinates in the field of physics, electromagnetic field. Spherical coordinates are ideal for problems involving radial symmetric fields, such as the electric field around a point charge or the gravitational field around a spherical mass. These coordinates simplify the expressions for these fields and their integrals. Quantum mechanics. In quantum mechanics, spherical coordinates are used to solve the Schrödinger's equation for systems with spherical symmetry, such as atoms and isotropic harmonic oscillations. The hydrogen atom is a classical example where spherical coordinates are essential. The applications of spherical coordinates in acoustics. Spherical coordinates are used to model sound propagation from point sources. The crucial for designing acoustics in concert halls, speaker systems, and sonar technology. Structural engineering. In structural engineering, spherical coordinates help in analyzing stress and deformation in spherical structures such as domes, tanks, and pressure vessels. Mathematics. Integral calculations. Triple integrals over spherical regions are more easily evaluated in spherical coordinates. This is particularly useful for computing volumes, surface areas, and mass distributions of spheres and spherical shells. Partial differential equations. Many partial differential equations, such as Laplace equation and Helmholtz equation, have simpler solution in spherical coordinates for radial symmetric problems. Computer graphics and visualization. 3D modeling. Spherical coordinates are essential in computer graphics for modeling and rendering objects like spheres and other round shapes. They simplify the generation of vertices and surfaces of these objects. Elliptic coordinates. Elliptic coordinates are two-dimensional orthogonal coordinate system used primarily for solving problems involving elliptical geometries. These coordinates are particularly useful in problem solving where the geometry or boundary coordinates exhibit elliptical symmetry. Applications of elliptic coordinates in electrostatics. Charged ellipsoids. Elliptic coordinates simplify the solution of Laplace equation for the potential around charged ellipsoidal conductors, capacitors, analyzing electric field and potential between confluential elliptical plates with elliptical cavities. Current loops. Elliptic coordinates help in modeling the magnetic field generated by current carrying loop with elliptical shapes. Stress analysis. Elliptical holes. In mechanical engineering, elliptical coordinates are used to determine stress distribution around elliptical holes or inclusions in materials, which is critical for structural integrity assessment. Crack propagation. Studying the stress intensity factors around elliptical cracks in fracture mechanics. Flow around elliptical cylinders. Elliptical coordinates facilitate the analysis of potential flow and viscous flow around elliptical cylinders or objects, improving the understanding of drag and lift forces. Mathematics. Integral calculations. Areas and volume integrals. Elliptic coordinates simplify the computation of areas and volumes regions bounded by ellipses and hyperbolas. Green functions. Solving boundaries value problems involving elliptical domains where green functions are easily expressed. This was all about applications of coordinates. Thank you for watching the video.